This archived clip from Make Live is brought to you by DigiKey.
Join us live every second and fourth Wednesday of the month.
Well, hello and welcome to the Perth Artifactory. Perth hackerspace founded in 2009. We've got 40 members. Why don't you come in and have a look? Here we have the heavy tool area, which has drill presses and metal lathes, and Mildred, which is our CNC metal mill, Smorformat, our CNC router, dinosaur footstool, DJ table. This area is where we tend to have all our meetings. It's what we call the light industrial area. We have our 3D printer, some computers for the members to use. This is the Archiphone, our 30,000 volt musical instrument. And over in this area, follow me, we have our 2 incubator offices for small companies to set up and air condition, comfort, and innovate. Over here we have our electronics area, which is like a mess, which is oscilloscopes and soldering irons, all the usual goodies. Follow me out to the backyard. Interesting area, like most of it all in development. We have our greenhouses, the Biomass Aggregator, 70s party lights, and a wall which is just ripe for outdoor projection. Coming back inside, we have the Artifactory, very, very popular in the hot Perth summers, which reach over 40 degrees Celsius. When we have our experimental music nights and video nights, this is quite a popular place. Classic bit of 1942 in. The ever popular Artifactory fridge. Follow me and you'll meet Giant Robot, our techno-tiki lord and master. Open the greenhouse.
So here we have the Artifactory's automated biomass aggregator. We have a few members of the Artifactory who are interested in horticulture and biology and seeing what we can do with that. So we built this greenhouse, which was built out of rack framing, some plastic and simple automated watering system, which we built, which comes through irrigation pipes, goes back over to the wall where we have a computer-controlled automatic watering timer, which allows us to water the greenhouse at different types of the day. We're growing a variety of plants in here, depending on what the various people wanted to grow. We have a member who's very interested in looking at soil renewal and soil enhancement. So she's growing nitrogen-fixing plants here with the eventual hope of being able to do experiments to see how well each of these individual different types of species fix nitrogen in the soil and enhance the soil's quality. So we have some black locust here, we've got some sea buckthorn, some pigeon pea, which is a very well-known good nitrogen fixer, which is used to replenish soil areas. And a couple of members have some land in various places, so we grow them here and then we'll take them up there and plant them out. And then the goal is to be able to do soil measurements and tests to look at nitrogen levels, the levels of healthy bacteria in the soil. And hopefully, yeah, we'll get some good results from this.
Hi, I'm Jenna and I've been at the Artifactory for about 2 years. At the moment I'm working on a moving image carousel, a zoetrope for a local science outreach centre. I'm basically doing a project that gets kids excited about science and art. So it's a mechanical object with a hand crank so that the kids can learn a little bit about just the physics of the movement and the physics of the moving image, and also I'll get them to draw their own animations so that they can learn a little bit about putting together a moving image of their own. I would really like to see the maker community really develop educational projects of their own, so I think the hackerspace is the perfect place for people to develop kits for kids to get excited about science and art and to really start that learning process, to initiate the learning process by themselves so they can really just get excited and learn about the world, and I think that hackers are in the best position to do that.
Yeah.
Welcome to the Artifactory's laboratory of unnecessarily high voltages, and we're looking at the Archiphone here. The central unit has the Arduino that translates the MIDI signals and drives the synthesizer on board. The synthesizer then pumps out signals to 12 driver boards, these amplifiers, and they send signals to the automotive ignition coils, which then bump up the voltage to 30,000 volts. All very exciting. Let's see if we can make it play some tunes. Standard MIDI keyboard, standard Arcophone demonstration number 1. Everybody's favourite piece. And now we will see the Arcophone performing the Beer Barrel Polka. Now the motivation behind the Arcophone is that every hackerspace wants something that goes bzz, bzz, bzz in the corner, because that's what we like to do. We're all crazy mad scientists. And after getting a basic Jacob's ladder kit, we realised we could do a lot more with this thing. What we needed is like 12 Jacob's ladders, all under computer control, Arduino control, and played by a standard MIDI keyboard. And so we built one.
Hi, my name's Kai. I'm a member of the Artifactory. I've been here for about 2 years, done some really exciting projects with the guys here. It's been a really great 2 years. I've been asked to talk about my most recent project, which is a recycled solar can heater, which I built and has come out pretty well. I was running my heater, just had a standard inbuilt home heater, and didn't like the look of my power bill. And like anyone in the maker community, my immediate thought was, how can I solve this using recycled parts and ready available tools? A lot of people who I talked to about it had mentioned that the best way to get a really good heating of the air inside was to actually induce a coiling motion of the air inside the cans. And so to do that, instead of taking the tops and the bottoms off every can, I actually only took the tops off, and I punched 4 cross punches in the bottoms and twisted them so that I ended up with kind of almost a rotor at the bottom of each can. So when I put them end to end, I had a series of propellers that were stationary to start the air rotating as it sucked through the cans. The main problem with that is that I have 63 cans in the whole system. And what that does is actually that over the source of those 63 cans, it actually puts a big resistance to airflow up, which I hadn't really thought of when I put it together. So my initial fans that I plugged into it were not powerful enough to blow air, and it would be blowing air in as fast as it could, and a slight trickle would come out. A very hot trickle would come out at the end, but it was not nearly kind of the throughput I needed. So in order to do it, I had to look at different kinds of fans to use. I think that it is a project that a lot of people could contribute to. Some of the ideas that were bandied around just in the Artifactory is the potentiality of incorporating an Arduino into the actual project, so that you have a temperature sensor in Arduino, so when the temperature reaches a certain level inside your house, it kicks the fan on to start blowing the hot air in. I think it would be really neat to do some actual science and graphing with air throughput versus temperature to find the optimal airflow through that gives you the optimum temperature coming out. At the moment I'm using a solar panel to actually power the fan, and maybe people could suggest better ways of inserting some kind of battery system so the power could be stored and then used more efficiently, so it would work in cloudy days, because it does actually create heat even on cloudy days, but then the fan doesn't work because there's not enough sun for the solar panel. So I think there's a lot of potential there for people to build their own, find the best way to get it working, and maybe share their experience online.
Well, thank you for visiting the Perth Artifactory. It's goodbye from me, and goodbye from Hand-Ass Frog. Now, back to more making.